Alright, let's get our hands dirty. You've heard the name Java tossed around, maybe in a coffee shop, maybe in a movie about hackers. So what is it, really? Think of it as one of the most versatile, reliable, and widespread toolkits in the digital world. It's not a physical tool, of course, but a programming language. From the tiny chip in your smart fridge to massive, globe-spanning corporate systems, Java is often the powerhouse running behind the scenes, quietly making everything work. It's been around for a while, which, in the tech world, means it's been tested, broken, fixed, and perfected over decades. That's a good thing. It means it's stable, secure, and has a massive community of builders just like you. Every great project starts with setting up your workshop. You need your tools laid out, your bench cleared, and your materials ready. In the world of Java, our workshop is digital. The first and most important tool we need is the Java Development Kit, or JDK. This is the master toolkit. Just download the installer that matches your operating system and follow the on-screen instructions. It's a simple wizard click next, agree to the terms, and let it do its thing. Once the JDK is installed, you need one more thing, a good place to write your code. This is called an Integrated Development Environment, or IDE. For beginners, I highly recommend starting with something like IntelliJ IDEA Community Edition, Eclipse or Visual Studio Code with the Java Extension Pack. After installing both the JDK and your chosen IDE, there's a quick check to make sure everything is connected properly. Open up your computer's command prompt or terminal and type Java version. This is it, the moment of truth. Fire up that IDE you just installed and create a new project. The IDE will ask you a few questions like the project name. Let's call it My First Project. Inside your project, you'll need to create a new Java file called helloworld.java. Now type the following code exactly as written. Public class, hello world, public static void, main string args, system out println, hello world. With the code in place, it's time to bring it to life. Look for a green run button and click it. In the console window, you should see the beautiful, glorious output. Hello world, take a moment to savor this. You wrote instructions, and the machine obeyed. You are officially a programmer. Now that we've proven we can make the computer talk, let's learn how to make it think. To do that, we need to give it a way to remember things. In programming, we do this using variables. In Java, when we create a variable, we have to tell the computer what type of information we plan to store in it. Some of the most common data types are int for whole numbers, double for decimal numbers, boolean for true or false values, and string for text. Once you have variables, you can start performing operations on them. You can do basic math, just like on a calculator. For instance, you could have two integer variables, and then create a new variable to hold the total. The computer will look inside each variable, add them together, and store the result. Let's try a quick experiment. Modify your Hello World program to calculate your age using variables for birth year and current year. This demonstrates the core loop of programming. Store data, process that data, and display the result. A program that just runs straight from top to bottom is useful, but it's not very smart. The real magic happens when our programs can make decisions based on conditions. The most fundamental tool for this is the if-else statement. You start with if, followed by a condition in parentheses. If the condition is true, the code in the first block executes. Otherwise, the else block runs. For example, checking voting eligibility. The program will check the age and print exactly one of two messages. It can never print both, and it can never print neither. You can chain these decisions using else if for more complex scenarios. The computer checks each condition in order until it finds one that's true or hits the final else as a catch-all. Sometimes we need to do the same task over and over again. Imagine printing numbers from 1 to 100. You could write each println statement manually, but that would be tedious and inefficient. This is where loops come to the rescue. Loops allow us to execute a block of code repeatedly until a certain condition is met. The for loop has three parts: initialization, where you set up a counter, a condition that keeps the loop running, and an increment that happens after each iteration. This example runs exactly 10 times. To print numbers from 1 to 100, we use this elegant solution. With just 3 lines of code, we've accomplished what would have taken 100 lines manually. The while loop is simpler. It repeats as long as its condition is true. You use it when you don't know ahead of time how many repetitions you'll need. Just make sure something inside the loop eventually changes the condition to false, or you'll create an infinite loop. As programs get complex, we risk creating a tangled mess. Imagine building a car by welding every piece directly onto the frame in one continuous process. It would be impossible to manage. Instead, we build components that work together. In programming, we do the same thing using methods. A method is a name block of code that performs a specific task. Here's a method to greet a person by name. The name parameter allows us to pass information into the method. Methods can also return values. This addition method takes two integers and returns their sum. We can then use the returned value in our program. Let's refactor our age calculator. By creating a dedicated method, our main logic becomes much cleaner and more organized. We've encapsulated the age calculation logic into its own reusable tool. The real world is more complex than simple numbers and text. We think about a car with color, model, and speed, or a dog with a name, breed, and the ability to bark. Object-oriented programming lets us model real-world things in code. A class is the blueprint defining properties and behaviors. This car class defines what it means to be a car in our program. To create an actual car, we use the new keyword. This creates a car object in memory. We can then set its properties and call its methods using dot notation. This is the essence of OOP, modeling problems as interacting objects. Things will go wrong. Your code won't compile, programs will crash or produce wrong answers. This isn't failure, it's a valuable part of building. The first rule of debugging is, don't panic. Java will give you error messages that tell you the problem type, description, and exact line number. This is your treasure map. Go to that line and look for simple typos like missing semicolons or misspelled variables. The journey you've started today is just the beginning. You've learned the essentials, from setup to classes and objects. What's next? Build something. Start with a simple calculator or text game. Keep building, keep breaking, keep learning. You have the tools. Now go make something cool.